Well, hey everybody, welcome to Titan Missile Museum. My name is Chuck. I'll be your guide on the tour today. We're going to head down underground in just a minute. But before we go, some housekeeping things we should talk about. First of all, there is nothing secret here anymore. So I encourage you to take pictures of every last square inch of this place and post them on your Facebook site or your blog so that your friends can see what a great time you had here today. You certainly picked a beautiful day to be here. Okay, the other thing is that everything you see up on the surface and down underground, those are one-of-a-kind artifacts. We don't have any spares or replacement parts, so we're going to ask your cooperation. Please, please help us preserve this stuff for as long as possible by resisting the urge to touch things. So, good. After the tour, you are welcome. In fact, I encourage you to come up here, head over to the missile silo and to the engines. Take a look at the engines, climb up on the silo, have a look down inside the glass at that monster missile down there. It is a really tremendous sight, and I don't want you to miss out on that. Okay, when we go downstairs, we are going to go through a heavy spring-loaded door. I want you to hold that for the person behind you. The stairs are a little steep, so watch your step and use the handrails. Those of you on the elevator, stick with my partner Steve. He will get you safely down underground. Let's go. All right, welcome to the underground. You are about 35 feet, about 10 meters, give or take, below the surface, so not super deep, but deep enough, we hope. This area that you just came down through is called the access portal, built to very high industrial standards, but regarded by the Air Force as being soft construction. And what that means is that this area is not expected to be able to withstand the effects of a nearby nuclear detonation. In a near hit, likely all of this would just cave in. Everything from here in is hardened, and that means it's designed with survivability in mind. The walls here are about 4 feet thick, a little over 1 meter thick. There's a gazillion pounds of rebar inside the concrete. The entire outside is steel plated for EMP protection. The doors are made out of I-beams, welded edge for edge. They're about 1 foot thick, about 30 centimeters thick, and are designed to withstand an overpressure of about 1,000 psi. Now, you don't need to understand anything about PSI, pounds per square inch. All you have to do is put that in perspective. These will withstand 1,000 psi. The average stick-built home would be entirely flattened at about 5 psi. So you begin to get a sense that this place is pretty well fortified against nuclear attack. Okay, when the crew got down this far, there weren't any more secret codes like you saw in the video, but you do need to have the cooperation of the crew inside to get in. And so what you do is you pick up this phone right here, say, potentially, hi, we're here. You have to push a button right here. The crew also has to push a button like that inside the control center. And when they do that, when those two buttons are pressed, a big hydraulic system will retract these big pins from the edge of the door. And then by tradition, the lowest ranking member of the crew gets to pull the door open by hand. So let's go inside. Okay, this is the blast lock. And a blast lock is exactly the same idea as an airlock in a spaceship or a submarine. And the idea is you got two big heavy doors. You got that one out there. You got this one right here. And both of these doors cannot be opened at the same time. So when the crew opens that door to come in, they find this door closed. And before they can open this door, they have to close that one behind them. That way, one door is always closed. Blast cannot get into the complex. Hence the name blast lock. Okay. We mentioned that the walls are really thick, like 1 meter thick. And the reason that the walls are so thick is that in a nuclear detonation nearby, a huge shock wave is going to come rolling through the ground. And if the walls weren't really big and thick, they would probably break up. We don't want that. But just as important as protecting the walls, we want to protect all the stuff inside the walls from that big shock wave as well. And so from this point forward, everything regarded as mission critical is hung on springs. All the lights, emergency lights, status lights, these big breaker boxes are hung on spring cylinders. There's a lot of slack in the electric wiring. So if these things bounce up and down, the wiring won't tear loose. This is a technique called shock isolation. You will see it everywhere you look as you get further inside. So just one more quick point about the door. the doors, I should say, the doors weigh, anybody, can you ever remember from the video how much the doors weigh? 6,000 pounds, 2,700 kilos, and they move with remarkable ease. They've been hanging here for 50 years now, and they're still a quarter inch off the floor like they were when they were installed. And that kind of denotes a quality of construction made possible only by copious quantities of your tax dollars. So let's head into the control center. Well, welcome to the control center. You can take your hard hat off in here if you like. There's plenty of headroom in here. You saw in the video that this is a 3-story building. So up above us is the crew's quarters. Down below is an equipment room. You're on level 2, the center level of the control center. And the cool thing about the control center is that the 3 floors are not attached to the walls. The entire building is bolted together and suspended from 8 huge springs around the perimeter of the room. So when we came in over here, there's a gap that little bridge goes across, and it's a gap about so wide where the walls and the floors don't meet, and they refer to that as the rattle space. So in response to a shock wave, the entire building would just sway back and forth or bounce up and down, and presumably we would all be safe. All right, let's take a look around the room and see what there is to see, starting over here. That big silver thing is our fresh air intake. Those of you standing over in that area can actually feel air blowing in. Right behind that wall is an air shaft that goes all the way to the surface. And there's a big fan on level 3 that pulls fresh air down for the crew. Now, the problem with that is that in a nuclear detonation, a shock wave could come roaring down that air shaft, blow into the room, and essentially blow the place apart from the inside out. And so to prevent that from happening, inside that big silver thing is what's called a blast valve. And blast valves can automatically sense the approach of a shock wave coming down the air shaft, slam shut very quickly, protect the crew, and put them on recirculated air. Now down below on level 3, in place of the thing, is what looks like a great big submarine hatch. And you can unbolt it and swing it open, and you can crawl through a dark 10-foot long tunnel, typically littered with dried out mice and lizards, and you meet up with that air shaft, and you can take a ladder to the surface. That is the emergency escape in case the access portal out there really does cave in. Okay, what else? The big red safe over here is called the IWO Safe. IWO stands for Emergency War Orders. A lot of the crew used to call this the go-to-war safe. There are 2 combination locks, one for the commander, one for the DEP. Of course, they know their own combination, but they don't know each other's, so they both have to agree to get inside the safe, and we'll talk about what's in there in a few minutes. These 3 racks of equipment are all communication gear connected to all those big antennas up on the surface. This is the alternate launch officer's console called the A-Lock, and it's the control panel for all the communications equipment. From here, you can make the antennas go up and down and change channels and frequencies and what have you. There's a microphone, a speaker, old-style rotary telephone. This is our launch clock called the IWO clock, and it is a spring-wound 8-day clock set to Greenwich Mean Time. Military calls it Zulu time. And the advantage of Zulu time is that there are no time zones, right? So that's really important to keep all your troops on the same page. So rather than Eastern or Mountain or Daylight or whatever, it's just Zulu time. Very important so that you don't end up with some wayward crew somewhere launching their missile, an hour early, for example. You don't want to tip your hand like that in a nuclear war if you can avoid it. We get our electric power from the power company, just like you. The difference for us is we can't ever afford to have the power go out, ever. Not even for a few seconds. So if the power goes out, down on level 3, out in the silo, we've got a great big generator that'll kick in automatically. But it takes, a minute or 90 seconds for that thing to warm up before the lights actually come on again. So to tide us over what would be that minute or minute and a half blackout, downstairs we have 2 huge batteries. And those batteries can carry all the critical equipment until the generator kicks in. So we're never without power down here. What else? This is the butterfly valve coated switch control. We're going to come back to this in a few minutes. This is launch sequence. Target selection, re-entry vehicle status. These are key switches to choose air burst or ground burst on the weapon for each of 3 separate targets. So we only have one bomb, but we can shoot at one of 3 targets, and we can select that target right here. We'll talk more about that a little bit later. Air burst typically is going to be about 14,000 feet in the air. Ground burst is going to be boom, when the RV actually impacts the ground. The entire missile and everything required to launch it runs on 28 volts DC. And the reason for that is so that we can launch the missile on battery power alone if worse comes to worst. And this is our control panel for monitoring 28 volt power right here. These are just circuit breakers for critical circuits in a silo and control center, just like you've got at home. And this big thing is called the MGAC, the Missile Guidance Alignment Checkout Group. This is how we tell the missile where it's going. So all the targeting information is fed from the MGAC into the flight computer on the missile from punch paper tape like this. Very crude technology, but extremely reliable. Punch tape will retain data decades longer than a compact disc or a magnetic tape. So it's a very secure method of data storage. All right, let's talk about how to launch the missile. First of all, the only person in the United States who can authorize the use of nuclear weapons is, right, the president. And wherever the president goes, he's followed around by a guy with a briefcase. And in the military, they often refer to that briefcase as the football. And inside this briefcase, now I've never seen one of these things, so I'm kind of guessing, but inside the briefcase, the president can open that up, and inside there's a transmitter. And the president can push a button or do something, who knows exactly what. And it sends a message to the Pentagon, which says, in effect, it's time to go to war. So when the Pentagon gets that message, they relay it to 2 command posts. And those 2 command posts relay it to us and all the other missiles. Comes over these speakers for the commander, over those for the deputy. And the message is it's like a long sequence of letters and numbers. Commander and I will grab for our top secret decoder books, and we'll begin to fill out a form inside, much like this one, with the letters and numbers that we hear. When we are done filling out the notebooks, we'll swap notebooks. They read the message for us again so we can check each other's work. And if we agree that we've copied the message correctly, then we have what is called a valid message and authorization to take our locks off the safe. So the first thing we take out of the safe is a big group of authenticator cards, much like these. And in our message, we got a secret code word. And we're going to look at the first 2 letters of that code word, and we're going to look for those 2 letters on the card here that we got out of the safe. Let's say it's XB. So we're going to take this card, and we're going to open it up, and out of this card, we're going to pull out another card that has the whole code word on it. If the code word here matches the code word here, then this is not a drill. This is a legitimate order to launch. So the next thing we would take out of the safe is our launch keys. It takes 2 keys to fire the missile. We'll put a key in right here for the commander. Put a key in way over here for the deputy. The keys are far enough apart that not even a long-arm guy like me can reach them both. And I have made numerous attempts, I want you to know. The keys must be turned within 2 seconds of each other. Click, click. So if you miss that window, you got to do it again. And you need to hold the keys for a few seconds to get the launch going. This process guarantees that 2 people are going to be required to launch the missile. Right? Always takes at least 2 people to fire a nuclear weapon. What else? We get in our secret message also the time of launch. Write it right across the face of the clock with what amounts to a crayon, so you don't forget. And last but not least, we get the code for the butterfly valve. Now, important point. Up on the engine, which you can take a look at after the tour, there is a valve on one of the propellant lines. It's called the butterfly valve. Works like this. And that valve has an electric lock on it. And that lock prevents the valve from opening until you enter a secret code down here to unlock it. And that code goes right here. Now, the code is not in the red safe. It's not in a file cabinet anyplace. It comes in with the order to launch and goes right here. There are 6 little wheels on this switch, and each little wheel has 16 letters of the alphabet. So what is that? 16 to the 6th power. Do the math. How many combinations are we talking about? And the correct answer is a lot. Just a little shy of 17 million combinations, only one of which will unlock the valve. More than that, you can't just come down here with your coworkers one day and decide, let's start guessing. I mean, given time, you could make your way through 17 million combinations, right? Except that this only gives you 7 chances to get it right, after which it commits electronic suicide and takes you off alert until somebody can come down here to fix it. Not a good thing to have happen on your watch. So the crew never played with this thing. They tested it every day, but they never played with the real code. So don't do that. All right. So to launch the missile, you need to accomplish 4 things. And they are authenticate the message, install the keys, determine the time of launch, and enter the BVL combination. And once you've done that, you're good to go. You, sir, have a seat right here, please. Now, before we actually turn keys and launch, let's just talk nuclear philosophy for a minute, because the mission is really important. So Titan II is built on this premise called peace through deterrence. Right. You weren't all sleeping during the movie. That's good. How many of you guys have seen the movie Dr. Strangelove? Anybody? All right, a few of you. Okay, those of you who have not seen it need to promise me that when you get home, wherever that is, you will rent or stream or do whatever it is you watch movies anymore. Dr. Strangelove is a kind of a dark comedy about an accidental nuclear war. It came out in 1964. Stars Peter Sellers in 3 separate roles, directed by Stanley Kubrick. Same guy that did 2001, Clockwork Orange, Full Metal Jacket, a bunch of others. I mention it because I saw the movie again for like the 41st time a couple of weeks ago, and I realized that Dr. Strangelove has the best definition of deterrence that I have ever heard, and I made a point to remember it. Dr. Strangelove said that deterrence is the art of producing in the mind of the enemy the fear to attack. And how we did that with Titan II is that we made clear to the Soviets that we would use this only to retaliate. And more importantly, we made clear to them that 35 feet under the desert floor here in our fortified concrete bunker, we can survive their first attack so that we can retaliate. And if we're forced to do so, the consequences for them are going to be so unspeakably horrible that maybe they would prefer not to get into it with us in the first place. In a nutshell, that's deterrence. And it works pretty well. But if it ever goes south, for whatever reason, you need to make good on your threat to retaliate. And that brings you to a concept called mutual assured destruction, MAD, MAD, appropriately enough, in which the enemy fires at you, you fire back, everybody dies, end of story. It's the threat of mutual annihilation, coupled with the knowledge that there is no defense against a nuclear-tipped missile, that made Titan II such a potent deterrent force. But for purposes of our discussion, Commander, we will assume that peace through deterrence has gone out the window, and now it's payback time. So I'm going to give you a brief countdown, 3, 2, 1, 0. And when I get to 0, I want you to, with your left hand, crew always use their left hand, turn the key, it goes about a quarter turn, till it stops, and hold it till I tell you to let go. And things happen very quickly, and I will attempt to keep up. All set, Commander? 3, 2, 1, turn keys. Hold on. Okay, you may release. That's all there is to it. The green light turns on, says launch enable. For all intents and purposes, that little green light should say, welcome to World War III, because that's pretty much what it boils down to. Batteries activated turns on means we have 2 batteries aboard the missile that are charging up right now. Those batteries are going to supply all the electricity for the missile while it's in flight. It takes 28 seconds to charge the batteries. When the batteries come to full power, the missile will switch to internal power. That means it's on its own. The silo door starts to slide open. When it slides far enough, it'll slide through those radar beams on the surface, set off the alarm. That gives us silo soft. Guidance go means the internal guidance computer on the missile is now running the show. In a few seconds, we're going to have main engine start. When the engine starts, we'll have a huge fire in the silo. We'll get a very loud fire alarm and indications indications we have fires burning. Build up thrust, pop the hold down bolts, and off you go into the wild blue yonder, as they're fond of saying in the Air Force. Important point here, 58 seconds from key turn to liftoff. There is no oops switch. So you cannot stop the missile. You can't blow it up or shut it off or send it somewhere else. It's gone and there's no getting it back. It's going to fly, what do we say, about 35 minutes. It's headed right here for Target 2. That's a classified target. The crew didn't know where it was, and we still don't know today. And in 35 minutes, boom, Target 2 just disappears from the face of the Earth inside of a fireball some 3 miles, 6 kilometers in diameter, and brighter, it is said, than 100 suns. Nicely done, Commander. Now, your job isn't quite done yet. You need to sit down here and sweat for a little bit. Your orders now are to wait for further orders. So we have nominally 30 days of food, water, air, and gas for the generator. So we have to wait 30 days and hope that the radio will squawk or maybe the phone will ring and somebody will call us and tell us what to do next. And if at the end of 30 days you don't hear anything, well, guess why? There's nobody left up there to hear from. So it's just you and me and our 2 crew pals, the 4 of us, down here nice and cozy. And since you are the ranking officer, you have 2 choices that you could make. One is that you could stay down here until the air runs out and suffocate to death. Or you could go out the emergency escape hatch into the nuclear wasteland above and take your chances. Your call. All right. The good news is that this brand of deterrence kept us out of that nuclear nightmare for more than 50 years, and we hope it'll continue to do so in the future. The bad news is that this same brand of deterrence has just about zero effect on our new crop of enemies here in the 21st century. So, on that happy note, let's go out and see if the missile is still here. Get your hard hat on if you would, and we'll go out and have a look at the missile. Okay, watch your step. Head right over this direction. We've got a couple of windows in the silo. I'll give you a really good look in. Watch your step. Watch your step. Head right over here. We've got a couple windows in the silo. I'll give you a really good look. Right over this way. Step right over this way. We've got a couple windows in the silo. I'll give you a good look inside. Right over this way. Okay. I think we're all here. So this is Titan 2. You're looking straight across at stage 2. If you look down between the O and the R and the word force, see where the metal changes color, that's the separation point for the first and second stage. Well, Titan 2 had a design life of 10 years. So they built it and they figured, well, we'll use this for 10 years. We'll move on to something better. But it turned out to be such a successful system that they kept it online for almost 25 years. And in the end, the decision to decommission Titan II was not made because anybody thought these were old and unreliable or leaky and creaky, as they say in the military. The truth is that by 1980 or so, these had just become insanely expensive to keep operating. The maintenance costs for these were well north of $1 million per missile per year. So the Air Force realized they could save themselves a bundle of money by pulling the plug on Titan II, and that is exactly what happened. So the important point here is that the retirement of Titan II had nothing to do with START or SALT or treaty with the Soviets or anything like that. It was economics, pure and simple. And so when that day came that they decided to retire the missiles, they would pick a particular site. They'd come out, they'd pump all the propellant off the missile, haul it away, store it someplace. And then the missile would be pulled out in 3 separate pieces. Warhead comes off. Stage 2 comes out. Stage 1 comes out. And when the missile was gone, then the salvage guys came in and stripped out everything they thought they could sell at a junkyard. It's a pity we didn't have eBay back then, because you could have built one of these in your backyard just by buying stuff on eBay. So the salvage guys took everything they thought they could sell in a junkyard or somehow. And when the salvage guys were gone, then the demolition guys came in, and they used more than 1.5 tons of high explosives to blow off the top 30 feet, roughly 8 meters of the silo. And all that rubble kind of was pushed inside the launch duct to fill up the hole. And when they were done, then they came out and put put a big concrete cap over the ruins, covered it all over with dirt, graded the surface to kind of make it look like it used to, walked away and called it a day. And this is the last one, the last remaining intact complex. Same missile, by the way, Titan II, same missile as used in the manned Gemini space program. So Neil Armstrong, first guy on the moon, got his first ride into space on a Titan II, just like this one. And then after the program, Titan II was used to deploy a number of satellites for the Department of Defense, for NOAA, for NASA, some other people. So it had kind of three uses in its life: as an ICBM, as a space launch vehicle, and as in the manned Gemini space program. And by the way, just kind of real quickly, because we have a couple of minutes here, I'll just point out that just like everything in the silo is hung on springs to protect it from shockwave, the missile also is hung from springs. In fact, you can see them in this photograph right over here. There's a large silver ring that the missile actually sits on, attached to that by 4 big explosive bolts. And then that ring, called a thrust mount, is suspended in the silo by 4 huge springs. So that gives the missile the ability to kind of rock back and forth and ride out a shockwave in the event of a nearby nuclear strike. Okay, we have a few minutes for questions, so I will take those and then we will head back up topside. Okay, this is the optional explanation of the azimuth alignment system. Okay, somebody asked, what's the purpose of this big platform right here? And this is part of the old guidance system. You can see there's a photograph on the wall right back here that shows the whole setup, most of which has been removed now. So there was this big gizmo on top here called the azimuth alignment autocollimator, and it shot a beam of light through this porthole into an open hatch on the side of the missile and into a window on the side of the inertial measurement unit. That's the gizmo that actually has the gyroscopes and so forth in it that tells the missile computer how to steer the missile. And there's a prism on the gyroscope platform in the IMU, and that beam of light is picked up and shot back toward this thing, where there's a comparator that will compare the two beams. And if those beams don't line up precisely, it means the gyroscopes are drifting. So then this thing would send a message to the MAGAC back in the control center, which would send a message to the IMU saying, in effect, tweak the gyros. Simple as that.